parts that are related in the triangle above was we had sine A and angle A. So we had side A and angle A. We had side B and angle B. And if we have these side and opposite angle pairs, we can apply this sine law ratio. So the ratio of these, the opposite side and the angle, sine of the angle, is proportional, is the same for all angle and opposite side pairs. And again, I made a note here that we can compare them proportionally because when we use sine, we're actually talking about lengths instead of angles anymore. So we can't do this proportional relationship with angles, but we can do it with the sine, because the sine, the angle A, oops, I should make sure we're clear on that. That's sine of angle A. The sine values are talking the same language. We're really talking about length here. So that we've changed that angle measurement into a length measurement, and now we can compare this length with this length with this length, and those length ratios are proportional to each other. And this is when we have angle and side opposite pairs. So what happens when we don't have opposite side and angle pairs? So in this case here, we have something called side, angle, side. So I don't have this angle, so I don't have a pair here. I don't know that side, so I don't have a pair here. I don't know this angle, so I don't have a pair here. So what do I do? Well, let's just see what we can do here. So first of all, could I just use Pythagoras? Can I just say 8 squared plus 10 squared equals c squared? And we have to say, no, this is not a right triangle. Pythagoras only works for right triangles. Okay, so in this case, since 50 degrees is smaller than the 90 degrees, if I had 90 here, that would work. Okay, but since 50 is smaller, this side C is going to be shorter than the length I would get using Pythagoras theorem. So let's see if we can come up with some relationship here. So I want to write an expression for these different parts. So first of all, the x part here, this length here, I can say that x divided by h is equal to cos. So I'm just going to write that down. X divided by 8 is equal to the cosine of 50 degrees. So I'm just going to say x is equal to 8 times cosine of 50 degrees. So 8 cos 50 represents my x value. The y value here is just going to be the y divided by c. So I can say y divided by c is equal to well, I can't say that, sorry. Okay, so the y value, we can't do that. So we're going to have to do the y value like this. So we don't have anything in this triangle, so we have to connect it through that length of 10. So I'm going to say that y is equal to 10 minus this length here, which was 8 cosine of 50. Okay, so y is equal to 10 minus 8 cosine of 50 degrees. And then the h, we'll do this using the angle 50 degrees, and we did this before. We had the height over the hypotenuse is equal to sine of 50 degrees. So the height is equal to 8 sine 50. So I'm going to write that as 8 sine of 50 degrees. There we go. Now, looking at just the shaded triangle then, I'm going to write a Pythagorean relationship for that shaded triangle. It's going to look like this. For h, it's going to be h squared plus y squared equals c squared. So I'm going to write c squared is equal to h squared is going to be 8 minus 50 degrees squared plus y is going to be, y will be 10 minus 8 cosine 50 degrees squared. Okay, so a squared plus b squared equals c squared. And I'm just going to expand this out. Well, we can just leave it like that, but we can just expand this out too, and we can see what it looks like. C squared is equal to 64 sine squared 50 plus, distribute this out, 10 squared. 8 times 10 is 80. Negative 8 times 10 times negative 8 is 80, so I get negative 160 cosine of 50 degrees plus, okay, when I multiply, square that out, I'm going to end up with 64 cosine squared of 50 degrees. And there is some stuff here that I can work with. So I have, what is it I have here? I can group together these two terms, and I end up with, there's lots of things I can do. Well, I can just basically calculate this out if I wanted to. And this would then allow me to solve for the length of C. Okay? And just before I finish this, I just want to group a few things together because I'm going to do this algebraically as well. So I'm going to end up with sine squared, and I want you to notice that we end up with 64 sine 50, 64 cosine squared 50. So if I just factor out the 64, I get that. 64 times sine squared 50 plus cos squared 50. Well, that is an identity. Let me just finish writing this out. 160 cosine of 50 degrees. And so this is an identity. So this works out to be, that whole thing works out to be, oops, what happened here? That whole thing works out to be 1. And so that just simplifies down. Okay, so what does this look like when we can do more with this if we just generalize it? So we're going to try generalizing this.